We are looking at Maths 209. Congratulations. We are coming to the end of Maths 209 very soon, and it is a privilege to have walked through this course. It is a very interesting privilege to have walked through this course. All right. Today we'll be looking at interpolation of unequal intervals. The interpolation of unequal intervals. And we said there are two major players in this section. We have the Lagrange interpolation and we have the Newton divided differences. And so in this section, we want to study problems of interpolation when the values of the independent variable x are given at unequal intervals. And so the first major player, the key player we want to be looking at here is the Newton divided differences. Glory, the Newton divided. And what do we have to say? We said if the function y is equal to f of x be given at the point x0, x1 as we approach xn, we said we need not equally space them. And so if you are taking, for example, all right, if we have x0, x1, x2, x3 as we approach xn, all right, and you want to find out the divided difference of two of the intervals. So we're picking them 2, 2, 2, 2, we're saying if you are taking f of x0 comma x1, the answer to this is you will say f of x0 minus f of x1 over x0 minus x1. That's exactly what we are saying. Okay, let's look at another interval. If we're saying x1 comma x2, what would our answer be? Our answer will be f of x1 minus f of x2 divided by x1 minus x2. So if you are picking two intervals, as you take two intervals on the number line, you discover that this is what you're gonna have. Now, if you say you want to pick f of x2 comma x3, your answer will be f of x2 minus f of x3 divided by x2 minus x3. Glory. That's a beautiful thing. All these are for two intervals. When you are picking two intervals. Now, what happens when you want to talk about three intervals? When you want to say x0, x1, x2, what are you going to have? If you find out you're going to have three intervals now, you're going to have f of x0, x1. You see, we first pick the first two intervals, then minus the last two, f of x1, x2. Did you see that? And then divided by from this place to this place. You see? From x0 minus x2. Glory to God. Did you see that? When we are picking three intervals for three intervals. Let's do that again. If we have f of x1, x2, x3, what are we going to have? We're going to have f of x1, x2 minus f of x2, x3. All should divide fx1 minus x3. Glory to God. That's a beautiful thing. Okay, these are three intervals. For three intervals, what if we're gonna have x0, x1, x2, x3 for four intervals? What's it gonna be? We're gonna have f of x0, x1, x2, right? Three intervals minus f of x1, x2, x3. All should divide x0 minus x3. This is for four intervals. That's a beautiful one. Now we want to use this to solve a problem. We want to use this to solve a problem. We call down under the topic of Newton general divided difference formula. Newton general divided difference formula. Did you see that? Very, very interesting. Very, very interesting. All right. So we have gotten to a stage where we want to use what we just learned to solve a question. All right. We want to use what we just learned to solve a question, and we are looking at use the Newton general divided difference formula to find f6. To find f6. Look at it here. To find f6. Now the table will be given in the exam. The table is given. So what do you do? All right, what do you do? Now if you notice, the difference between 5 and 7 is 2. The difference between 7 and 11 is 2. The difference between 11 and 13 is 2. But the difference between 13 and 21 is about, is it 9? Yes. Is it 8, right? So that is a lot of gap. So we classify this under unequal intervals, because at this particular point here, the difference between them is what? Is 8. So that's a lot of gap. You understand? Adding or assume that the difference between this and this is 2 altogether, it will be called equal interval. It will be equal interval, and so we're not going to be using the Newton general divided difference at all, because like I said, there are two major players when it comes to unequal intervals: the Lagrange interpolation and the Newton divided difference. If it were to be equal interval, if that question were to be equal interval, you'll be using Newton forward interpolation or Newton backward interpolation. And because we are looking for f of 6, f of 6, you would have been using what? A Newton forward interpolation, because that is used to interpolate figures that is near the beginning of a table. That is near the beginning of a table. But because this is unequal intervals, what has made this unequal interval? The fact that the difference between 13 and 21 is 8. Did you see that? Is 8. So that is enough reason to tell us that this is what? Unequal interval. So let's go. Now, how do we get the number to write here? How do we get that? So what we do is we say 150, because if you look at this very well, you discover that that table there, 150 is what? X naught. F of x naught is 150, right? Let me write that quickly here. You discover that f of x naught is 150. You discover that f of x1 is 392. You also discover that f of x2 is what? F of x2 is 1452, and f of x3 is 2366. F of x4 is 9702. So how do we get the number here? How do we get this particular number here? What we will do is we'll say f of x naught minus f of x1 all over x naught minus x1, right? So that's to simply say 150 minus 392 divided by, so who is x naught? X naught is 5, divided by 5 minus 7. Our answer therefore will be 121. Glory to God. So the next thing for us to do, how do we get the number here? How do we get the number there? We simply say f of x1 minus f of x2 all over x1 minus x2. What we are simply saying here is 392 minus 1452 divided by 7 minus 11. Did you see that? And that will give us 265. So quickly write that down. 265. So we are going to observe the same pattern. Now I want to test your mind. What do you think this value here will be? The value at this point will be 1452 452 minus 2366 divided by 11 minus 13. Is that not? All right, that's a smart one. So we have 457, and then we have 917. We have observed the same pattern all through. So how do we get the functions here? What we're going to do this time around is to say 121 minus 265 divided by, did you see that? Now we're going to move, before we were taking two intervals, 5 and 7. Now we're going to move a further stretch. We're going to move like this. Did you see that? 5 to 11. 5 minus 11. And so when you move like that, you're going to have 121 minus 265 divided by 5. So you are going to have 1, 2, 3, 4. We're going to have 24, I believe. You're going to have 24. All right. So you do the same thing. You say 265 minus 457 divided by, so we're going to stretch it a little bit further, 7 to 13. Did you see that? 7 minus 13. And if you do that, you're going to have 32. 32. Again, we stretch it a little bit further and say 457 minus 917 all over 11 minus 21. If you do that, you're going to have 46. Is that cool? All right. Now, how do we get this person here? How do we get here? So we're going to say 24 minus 32 all over. Now, we're going to move from 5, before, for this particular function here, we moved from 5 to 11. Now we're not going to do that again. We're going to move from 5 to 13. Glory to God. So we're going to say 5 minus 13. So that will be what? 8 over 8, right? Which is 1, right? That is 1. So here we have 1. Glory to God. Minus 8 over minus 8 will give you 1. Is that okay? Now, how do we do the next one? What do we do for the next one? We say 32 minus 46 all over. So we move from 7 down to 21. You see that? We have skipped 2. So we said 7 minus 21. And our answer there is also 1. Is that okay? So we have 1. And then we have 0 here, because 1 minus 1 of course is 0, right? 0 divided by any number is 0. So that's okay. That's okay. Now that we have been able to build, our step 1 is to take the divided difference table, which we have done, number 1. Number 2 is to do what? Our step 2 is to write down the Newton general divided difference formula. That's a good one. All right. So we writing the Newton general divided difference formula. It goes this way. We said f of x naught plus x minus x naught, taking two intervals, x naught and x1. Then you come here and say x minus x naught, x minus x1, taking three intervals, x naught, x1, x2. Then you come here and say x minus x naught, x minus x1, x minus x2, taking four intervals, 1, 2, 3, 4. So I want us to memorize that right now. What is the Newton general divided difference formula? Let's memorize that quickly. We said f of x naught, yes, plus x minus x naught, taking two intervals. What do I mean by taking two intervals? Just write f of 1 comma this. You see? X naught, x1. Then come here and continue your story and say plus x minus x naught, x minus x1, f of, you see that? Taking three intervals. Now you have called two names here, right? You want to take three intervals. X naught, comma, x1, comma, x2. That's, you have called three names here now. Now, plus, did you see that? I come here and continue my story. X minus x naught, x minus x1, x minus x2. You see, I just wrote one story here. Here I wrote two stories. Here I wrote three stories. Do you see that? What do I mean by story? The first one I started with x minus x naught. And my second line I said x minus x naught not alone, x minus x1. In my third line I said x minus x naught, x minus x1, x minus x2. 3 stories. So when I get to the third line, I will call out how many intervals? 4 intervals. F of x naught, x1, x2, x3. Did you see that? Here I call 2 intervals, here I call 3 intervals, here I call 4 intervals. Did you see that? That is the formula, the Newton general divided formula. So after writing it out, then step 3 is to insert the points. So let's insert the point quickly. So we have f of 6. Meanwhile, we are looking for f6. You see? So you use the Newton general divided difference formula to find f of 6, f6. So anywhere we see x, replace x with 6. So this is, what is f of x naught? Is 150. Look at it here. 150 plus, so we are saying 6. The x now is 6. Anytime you see x is 6. 6 minus, what is x naught? X naught is, from here, you know this is x naught, 5. This is x1, 7. Let me write that down for you here. X naught is 5, x1 is 7, x2 is 11, x3 is 13, x4 is 21. You see that? Okay, so x naught is 5. Now multiplied by, what is f of x naught comma x1? F of x naught comma x1 is this person here. That was what you did to get 121, right? So multiplied by 121. Now plus, again we are at this stage now. 6 minus 5, 6 minus, what is x1? 7. Did you see that? Multiplied by 3 intervals. What did you use to get 3 intervals? Here, this is 24. Multiplied by 24. Plus 6 minus 5, 6 minus 7, 6 minus 11, right? 6 minus 11. Is that okay? 6 minus 11. All right. Multiplied by what? Multiplied by 1. Did you see? What did you do to get 4 intervals? Right here. Multiplied by 1. Is that okay? Now from there, the next one will be plus 6 minus 5, 6 minus 7, 6 minus 11, 6 minus, did you see? 6 minus 13, 13 multiplied by 0. Did you see? 0. So immediately you write multiply by 0, this place is wiped out. Is that not? 0 multiplies that and wipe it out. So your answer for F6 is 150 plus 121 minus 24 is equal to 252. Did you see that? Using Newton general divided difference formula for solving unequal intervals. Glory to God. Did you see that? So let's check if what we did actually makes sense. Look at, when it was 7, it was 392. It means once it's 6, it will be around 200 and something, right? Yeah, if it's around 6, it will be around this bracket, around this range, 200 and something. So that's 252. That's okay. That's okay. 252 makes sense. 252 makes a lot of sense to be around 6. Is that okay? All right. All right. Glory to God. So we are done with Newton unequal interval for divided differences. On our next chapter, we will be looking at the Lagrange interpolation. Meanwhile, you have a duty. I dare you to solve this problem. Find the polynomial. Find the polynomial. Find the form. Find the form of the function Find the form of the function f of x under suitable assumptions. Under suitable assumption from the data below. From the following data. So we have x, you have f of x, you have 5, you have 150, you have 7, you have 392, you have 11, you have 1452, you have 13, you have 2366. All right, find the form of the function f of x under the suitable assumption. I'm daring you to solve this. Meanwhile, there's a photo question I want to solve. There's a few photo question I want to solve. All right, it says if f of x is equal to 1 over x, then find f of a comma b and f of a comma b comma c. Glory, that's a beautiful one. Okay, let's solve for this first. What do you think f of a will be? F of a will be 1 over a. Since f of x is 1 over x, that means f of a is 1 over a. What do you think f of b will be? 1 over b. What did we say about taking two intervals, x0, x1? What we said is that what? We said f of x0 minus f of x1 divided by x0 minus x1. That's what we said. Okay, so if that is what we said, let's translate that here. It means that f of a comma b will be 1 over a minus 1 over b divided by a minus b. Glory to God. And so from here, if you do your normal arithmetics, you're going to have b minus a all over ab into bracket a minus b. Yeah. So if we switch this becomes negative 1 over ab, because this can cancel this one, but on the negative part, minus. By the time you multiply this one by minus, that's when you can have this. So you can cancel that and have minus 1 here. So minus 1 over AB. That's the answer to that question. Is that okay? So I dare you to do that of this, A, B, and C. So I'm just going to start that. Say f of A, comma B, comma C. Remember that when we take three intervals, x1, comma x2, we say our answer is f of x0, comma x1 minus f of x1, comma x2 divided by x0, comma x2, extra minus, sorry. So if we are saying f of a, b, and c, it means f of a, comma b minus f of b, comma c divided by a minus c. So what is f of a, comma b? We have done that already before. That's minus 1 over ab. What will be f of b, comma c? That will be 1 minus it will also be minus 1 over bc by common sense. Do you understand? If by AB we have minus 1 over AB, then by BC it will be minus 1 over BC divided by A minus C. Is that okay? So if you do your mathematics here, if you do your normal arithmetics, you're going to have minus C plus A over B into bracket AC. And then you're going to have 1 over A minus C. You're going to have multiplied by, yeah, you're going to have 1 over ABC. Glory to God. That's a good one. That's a good one. Excellent. Excellent. So we have come to the end of divided differences. Divided